This video will discuss Pythagorean triples. Pythagorean triple is a set of three natural numbers that satisfies the Pythagorean theorem. For example, I have a square constructed on one leg which is 3 by 3. You can see it is 3 by 3. And there is another square which is constructed on leg B which is 4 by 4. Then the number which is 3 square plus 4 square is equal to 5 square, which we can visually see it because the 3 squares and the 4 squares, they completely covers the square constructed on the hypotenuse, which is 5 squares. So these set of three numbers, which is 3, 4 and 5, and these three numbers satisfy the Pythagorean theorem. So these set of three numbers is one of the Pythagorean triples. Likewise, I am going to show you another Pythagorean triples. In here I have a square which is constructed on leg A which is 5 by 5. You can count these. The sides of this square is 5 and the other side is also 5. It is a square, so this is 5 by 5 square, and the yellow one is 12 by 12. If you count these are 12 by 12. So these two squares will completely cover the area of the C square. Like we can see it here, this covers part of the C square and the remaining part is covered by the square constructed on the other leg B. So the C square is completely covered by the area of the two square constructed on the two legs. So the number in this case is 5 by 5, which is 5, and the other leg is 12, and these two together, when they fill the C square, then the square formed is 13 by 13. By counting these sides of this square which is constructed on C, it is 13 by 13. So you can see here that is this one is 5 by 5, this is 12 by 12, and this is 13 by 13. So these set of three numbers, which is 5, 12 and 13, that is also forms a triple, which is also called a Pythagorean triple. So we saw the very first one, which is 3, 4, 5, one of the triple. The other one we saw in here, which is 5, 12 and 13, is another triple. Likewise, we can have many other triples, and these triples can be generated or can be found by using a polynomial identities. This polynomial identity is being discussed or given in the Common Core State Standard code A-APR.4. Now I am going to show you how you can generate the other triples by using this polynomial identity. The first example I have taken here, x is 2 and y is 1. Any value of x and y can be chosen to find the multiple Pythagorean triples. Condition is the value of x and y must not be the same. So this is the first example I am using when x is 2 and y is 1. So let me plug in these two values and let us see which is going to be the first Pythagorean identity. So I'm going to use my pen and I'm going to discuss. Let us find out. So the first one is x is 2 and y is 1. So if I plug in here, let me use this spot. So this part is going to be as discussed here, that will show me as C. So the hypotenuse is going to be x is 2, so 2 square plus 1 square, which is this part, and that gives me 4 plus 1, which is 5. So this is one number, we got it, that is this one, this thing, and this part is going to be A, and this is going to be B. So this is A, leg B, and this is hypotenuse C. So I found when x is 2, y is 1, we found the value of C is 5. Likewise, A is going to be which is 2 square, take away 1 square, and that gives me 4 minus 1, which gives me 3. So that is going to be leg A, and leg B is given as 2xy. The value of x as 2, so 2 times 2 times 1, which gives me 4. So we found the set of three numbers, which is 4 and 5 and 3. So using this polynomial identity, I was able to get another triple, which is 3, 4, 5. If I change the value of x and y, we'll get couple other Pythagorean triples, and I'm going to change the values and you can see what are the other triples we get. So the next triple I'm going to find by changing the value of x. Let us say if I change it to 3, so I get another triple, which is 8, 6, 8 and 10. If I continue changing the value of x, again 4, so I get 15, 8 and 17, or we can say 8, 15 and 17. This is another one. If I go back and change the y value as the 2 value, so I'm going to increase it, so I get 5, 12 and 13, which was also visually I demonstrated in the other the previously I did on the same video, but previously by using the triangle. So we can have any of these. If I keep changing these numbers, and I'm going to continuously change the 1 and 2, like 4 and 3, I get another one. If I change 4 and 5, x is 5, y is 4, I get another one. So we can get as many triples as we want to by changing these values. But as I was saying, that if I change the value, let us change the value of x as 3. So what happens here? X is 3, y is 3. So this is not going to form a right triangle because one of the side is 0. So if you have x and y, you cannot choose both of them as same, x equal to y. So this is not going to be a Pythagorean triple, and that is one of the reason I said we can choose any natural number, and the condition is the two values of x and y should not be equal. So that is what we get if I change these values. Let us say if I change this to 2, so I get 5, 12 and 13. If I change this one to let us say if I change y value as 4, so I get 7, 24, 25. All these different Pythagorean identities can be generated by using the polynomial identity, which is given here as x square plus y square quantity square is equal to x square minus y square quantity square plus 2xy quantity square. This particular identity is being discussed in the Common Core State Standard, as I mentioned, and it is written here. I hope you understand this polynomial identity, and the visual demonstration must be it is advantage for you to understand how this polynomial identity works and how this what is Pythagorean triples.